Hello, I'm Miguel, and we're doing our project on the collaborative visualization of solar system tracks. First of all, I'm going to go over what exactly solar system tracks is and what we added on to it. Solar system tracks is a JPL web portal that uses data from NASA of planets, asteroids, and moons. This data can be viewed through satellite photography and 3D terrain. What we're integrating into it is the collaborative visualization part, which allows users to examine the data together and collectively work on new ideas, projects in real time. This is a screenshot of the current solar system tracks that exist, and this is without our integration of it. And here you can see you could choose from planets, moons, and asteroids, which you could quite literally explore as you're about to see in the next slide. This would be a 2D view of the moon. In this view, you can see that it's part of our project, the collaborative visualization part, because it includes some tools that we added, such as the text box in the bottom left and the collaborative room session button on the top left. And you could also see the green arrows that we've drawn along with the green rectangle, some text, and some red lines. And this would be the 3D view of the same moon that we just saw in 2D, where you could see the same arrows, the same rectangle, the same text on the same location, just viewed through a 3D model, as opposed to the 2D photography that we saw in the previous slide. This is an outline of our presentation. First, we're going to go over the liaison and team introductions, then our project planning, feasibility assessments, then VR and the VR in the solar systems tracks, our avenues of research explored and the decisions, our software requirements document, project timeline, personas, use cases, and scenarios, our documentations, our collaborative session functionality in 2D and 3D tools, tools, modules, and functionalities, and finally, our conclusion and demo. So who are our sponsors? Our sponsors is the JPL team, headed by Miss Emily Law, along with Eddie, George, Richard, and Sean. And the goal they set out for us is to develop a network visualization software to support collaborative markup of solar system terrain. And I'm going to briefly introduce our advisor and our team members. Our project advisor is Dr. David Krum. Project lead is Montague. Project co-lead, Stanley. Our customer liaison and requirements lead is Christopher. Our architect lead is Abdullah. Our documentation lead is Zipeng. Our demo and presentation lead would be me, Miguel. Our QA lead, David Tang. And our components, UI backend database leads would be Jose, Odasys, and Johnny.
Hello, my name is Christopher Smallwood, and I'll be discussing the planning aspect of the project. The planning aspect of the project can be broken down into 4 phases: pre-preparation, preparation, implementation/testing, and closure. So we should begin with the pre-preparation phase. Before the team even began working on the project, we had to decide on which programs we would implement for communication, accountability, and archival purposes. To accomplish this, we implemented Discord for team communication, Outlook for communication with our liaisons, Zoom for meetings, and SharePoint for archives. Next, in regards to preparation, the preparation phase is when the team actually began to understand the project. It was during this time that discussions between the team and liaison were focused primarily on understanding the project without actually trying to code or implement any aspect of the project. That was all done in our implementation and testing phase. During our implementation/testing phase, we implemented an agile performance way of work, so that way we would be going back and forth between asking liaisons between what they would like, and then we would provide that for them. And then we'd constantly have that back and forth until we have a final product. And finally, we'd be moving into closure, in which case we'd be wrapping up our project, preparing our final documentations, our final notes, final everything on the matter, and submitting that to our liaisons, so that way if somebody in the future were to continue our work, they would have more or less a jumping off point instead of coming in blind. And speaking about our liaisons, let's move on to how we actually communicate with our liaisons. So our communication with our liaison is actually very straightforward. First, everything begins with our team meetings, in which case the team discusses the accomplishments, the actions items for the team, in which case what does the team need to do, as well as events, in which case there's event dates that come up in the future that the team needs to account for so that way everyone's attending what they need to attend. Next, they have the liaison meeting, in which case we relay everything that we discussed during the team meeting. The team discusses any ideas that they have towards the liaisons and how they'd like to move forward with the project, or how the liaison wants us to move forward with the project. We address concerns. If there is an issue with the project that liaisons want us to know about, or we want them to know about it, that will be the time which we would address those concerns. And finally, we would have the action items for liaisons, in which case we need something from liaisons provided to us. So that is during the time in which we let them know. Next would be the briefing email. The briefing email will just simply restate the events during the liaison meeting. And we'll schedule our next meeting. And in the event there's any documentation that we need to provide to our liaisons that was discussed during the liaison meeting, it is in that briefing email that we'll provide the documentation to our liaisons. And then after the email, we simply just have the time between meetings, in which case the team works on action items. We contact resources such as our other team members, our advisor, our liaisons, or faculty if we have any questions that we need to have asked that they can have answered for us. And we update deliverables. So if we have any documentation that's been changed during the time between meetings, it is during this time that we will update those documents. And that's pretty much how we communicate with our liaisons. And is at this time, I'll pass everything off to Abdullah, where he will talk about VR.
Hello, everyone. My name is Abdullah, and I will talk about virtual reality. So, first, what is virtual reality? Well, virtual reality (VR) refers to a computer generated simulation in which a person can interact within an artificial three-dimensional environment using electronic devices such as special goggles with a screen or gloves fitted with sensors. In this simulated artificial environment, the user is able to have a realistic feeling experience. So, virtual reality VR creates an immersive artificial world that can seem quite real via the use of technology. Through a virtual reality viewer, users can have a full 360-degree view. Also, virtual reality has many use cases, including entertainment, gaming, educational, or as a training tool. The solar system track portal has already a VR features implemented in it, where the user can use it by having a Google Cardboard or a set of a VR goggles. The user can open the tool panel to draw a path to float along with a full 360-degree view, as it's shown in the picture on the right. Unfortunately, due to the time constraints, our team has not able to implement the collaborative session aspect into the already built VR systems of the solar system track software. But we are hoping that the next team will carry on this project will have the opportunity to do so. So next, I'm gonna pass the slide to my teammate Montague.
Hello, my name is Montague, and I will be going over the feasibility assessment and how it helped the research and development for the collaboration component of the solar system trek system. The team utilized four main concepts: research and discovery, which helped us to understand the current software and technologies used; risk assessment, which allowed us to calculate the amount of time required for documentation and the development pipeline; feasibility development paths to determine possible approaches to developing our additions to existing software for a successful project; and decision and requirements to help inform the customer of limitations and clarifying the requirements. While researching avenues of application for the development of this collaboration component, the team split up to explore the use of Unity and the use of web-based technologies. Unity is a powerful platform with a strong ability to manipulate 3D data and create VR and augmented reality software. JPL provided the team with a past graduate student's VR Unity project utilizing the solar system tracks technologies. However, after extensive research, it was discovered that Unity's WebGL does not support mobile platforms while deployed on web. This would have forced us to deploy the solar system trek application on the App Store, which would have proved to be undesirable, cutting out a large user group. Unlike Unity, the research of web-based technologies would have been able to support users on all platforms. It was for this reason we decided to opt for a web-centered approach. The solar system track system is a web-based technology. This ensures seamless integration with the existing frameworks and system with little to no conflicts to be held. Other tools that we would be able to utilize is CCMJS, a powerful framework for 3D geospatial visualizations, and ArcGIS Esri, a geographic system for working with maps and geographic information. This will then enable us to manipulate and utilize various tools, for example, polyline and entity markups on 3D and 2D terrains. For the creation of the collaborative session, the team utilized Node.js and WebSockets. This then enabled us to encompass the existing capabilities of the Solar System Trek framework and connect them seamlessly into the collaborative aspect of the software. Next, I'll be passing off to my teammate, Odasys.
Hello, I'm Odasys. The requirements were drafted over a series of meetings between the team and JPL before the development began. The requirements specified the software and hardware requirements, as well as the features and functionality that had to be implemented. By using a scenario and a use case to help illustrate how a future user is going to interact with the system, this helped us generate the main requirements for the project. The requirements collected have to be measured against the actual purpose of the software application in order to determine which system features to include on a priority basis. Some features were new and specific to the implementation of Trek, while other features were carried over from the existing Trek web portals and adapted to work. Other features were less specific in its requirements than others, allowing the team to improvise and implement these features. When a future team gets assigned this project, the documentation we provide will show the technical details regarding the implementation to the software, as well as the technical challenges encountered during the development process, and illustrate all the features, components, and bugs the software has at the moment. The documentation can help the next team decrease time and effort required for testing, debugging, so they can quickly focus on building and developing menus and other UI elements to the software. This level 0 design is the core of a software that can be further broken down into multiple subcomponents. Each subcomponent is responsible for a set of related tasks, which is not shown in a local storage device on which product data is cached to and read from. The software uses the same backend web services as the existing Trek web portals, but provides front-end visualization and tools through the web application. Next up is Zipeng.
Hi, my name is Zipeng. I'm going to introduce the personas, use case, and scenarios. In our project, we create a document about the personas and use case. These personas represent different user type. It would be helpful to describe the real-world scenarios and purpose for our feeders instead of just highlighting a capability. Here is some example of personas, such as John is an ex-military, 35 years old, mission planner who worked for NASA. Nick is a 20 years old college student with a love for space. Tom is a 40 years old high school teacher who is currently teaching a science class. Each use case provides one or more scenarios, which is illustrate how the system interacts with the end user or other system, and it can achieve a clear business goal. This part is important for our project because it may help us find out who are we building this for, what is the user actually trying to achieve, what is the big problem that need to solving, and we can draft the requirement and clarify about what we should do next. Here is an example of use case. Nick is a 20 years old college student with a love for space. He is analyzing NASA's data on the Solar System Check portal. He wants to share the data with his friend with a love for NASA's data too. Nick and his peer want to collaborate in a smooth way while using the Solar System Check. If the Solar System Check persists a way for smooth collaboration, then Nick and his friends will no longer have to share screen with each other. Instead, Nick can create a room and invite his peer to join the room in the solar system track. Nick can share his waypoint and his peer can fly to the waypoint by clicking it. They also can communicate at the chat in the solar system track by texting. The cooperation work would not solve the problem for Nick's peer, but also other in the general public who wish to cooperate with the solar system track in a smooth manner. Thank you for your listening, and I will pass it to David.
Hi, my name is David Tang. I'll talk about the collaborative session features for our project. And one of the things that we can do is on the track, you can see that there's a collaborate button. And when you press it, you see a pop-up that says join/create room. And in there, the user can create a room. And what they do is they decide to type their username, type their room name, and set a password. And from then on, anybody else who wants to join that room, they can just make their own username, type that room name that they want to join, and enter that password, and then click join, and they'll be inside the room. And once they are inside that room, they can start chatting with all the users who are currently inside the room. And the other users, you can simply just hit the reply button and they can just type whatever message that they want. In addition to having rooms, we also have states. And what a state is for our software definition is that a state is just a copy of the planet. It just saves all the data, all the entities, everything else about it. And one of the things that we can do is export a state. And what that does is it creates a JSON file full of data, which includes the different line drawings, the color, the size, the shapes, as well as everything else. And then we can also import a state. So what that does is you just choose a JSON file, like you just choose the one that you just exported, put it in, and once you import it, you can see all the changes that was made, and that thing just gets revealed from the JSON file. So just basically just a copy of the state that you can see after you import it. I will let you see that there's like a bunch of 2D tools. There's a few of them right here, but I'll pass it on to someone else to go into detail later. And there's also the 3D tools that we can see. We can see that they're different from the 2D tools. And I'll pass it on to Jose, where he'll talk more in detail about these tools.
Hello everyone, my name is Jose Garcia. I'll be talking about the tool module. The tool module is a set of tools that a person may be able to use when joining a room on Moontrack. The tools are line drawing, polyline drawing, freehand drawing, text/point, waypoint, free camera, shape drawing. The line drawing is to draw a single line on the moon from point A to point B. The polyline drawing is to draw multiple lines by placing multiple points on the moon. The freehand drawing is to draw any shape of a line on the moon. The text/point is to place a point and text on the moon. The waypoint is to save the coordinates of the drawing and then use the name of the drawing to go to that specific drawing on the moon. The free camera tool is to move freely around the moon. This is only available for the 3D version of the moon. The shapes drawing is to draw different shapes on the moon. Currently, we only support circles, squares, and triangles. For lines, you can add color and width. For shapes, you can add color, size, and altitude. The text/point displays a box that asks the person to enter a text, the size of the text, the font style, and the color of the text. When drawing on a 2D version of the moon, it will automatically be placed on the 3D version and vice versa. Tool module improvements. The 2D drawing is made using Esri. The 3D drawing is made using cesium. The 3D lines appear to not have a curvature when placed on top of the moon. Thanks to our advisor and liaisons that spotted this. The waypoint only works for 3D. In the future, it can be implemented for the 2D. The text/point can be improved to the customer liking. The importing and exporting can have a potential bug but it is rare. All this will be in the documentation. Thank you for listening, and I will pass to Johnny Lee.
We were deciding how we should carry out the creation of the requirements, which was also called the design phase, where we figure out how different concepts to put together to carry on to an implementation phase. At the beginning of the second semester, from January 5th to February 26th, we implemented the design by creating code for it. Near the end of the semester, from February 26th to April 30th, we were making sure that the software is bug-free by creating tests and fixing any glitches or bugs. And from today, from till the rest of the very end of our entire project timeline, we have our closure where we're presenting our project to the general public.
Thanks, Johnny. So now that you've gone over the project timeline, I'll be discussing some of the technical cliffs and some of the things that we can look at in the future. Since we were implementing on top of existing software, we were introduced to a lot of new code. The Dojo Toolkit, which is a JavaScript framework, which is used for large-scale web applications, did not have as much documentation as we'd liked. The software also uses older versions of Cesium and Esri, which prevented us from using some of the features that are available in the newer versions. Some of the things that future teams can take a look at are expanding on some of the collaborative features, such as allowing hosts to control who can do certain actions in a collaborative session, implementation of collaborative VR/AR capabilities, as well as or the implementation of a detailed and structured database. We pondered on whether or not we should implement a NoSQL database or a SQL, but we never really got around to it due to its complicated learning curves and structures with the server infrastructure. So now I'll be going into the live demo to showcase some of our collaborative capabilities. So I'm currently loading up a instance of our software. Currently, it's being hosted locally. However, the next version will be hosted on the actual web. So here is our software. We have the collaborate button, which David went over. We have the chat box, and we have the tools module, which Jose went over. And to showcase our collaborative capabilities, I'm actually going to be opening 2 of these windows. So we have 2 instances of the software, and each one is different. I'm going to start off on the left side by creating a new room, and I'm going to join as Stanley. I'm going to create a room called, let's call it CVSST, and let's give it a password of 123. So let's create. And say I'm a scientist, I'm a mission planner. I want to draw a certain path from one point to another, and I want to make waypoints along that path so I can document some of the areas of interest. So what I'm going to do is I'm going to zoom in here, and I'm going to start drawing some points. So I can choose the color of this line that I want to draw. And let's do this. I'm going to start off at this point. I'm going to start off at this point, and I'm going to end at this point. Oh. Start here and end here. So now we have this line, and now I'm going to add some circles. So we have one there, and we have one there. Let's do that again. There we go. So now we have these 2 points right here, and I'm going to add a waypoint here. Let's call this point 1. And I'm going to add another waypoint right here. Let's call this 1.2. And so now I have 2 points created. And you know what? Why don't we label them as well? So we have point 1 here. Let's give it a font size. Let's color it. Point 1 and point 2. Give it a color. So now we have labeled points. And let's say I want to share this with somebody who is on the internet across, somewhere at their house. Who knows where they are? They can actually join this room and see all of these changes that we're making in real time. So why don't we do that? This browser on the right here shows another instance of our application. And this time I'm going to join the same room that we created, but with a different name. Let's say gym. And our room name was CVSST. The password was 123. I'm going to join it. And so now you can see as soon as you join, you have these 2 points already here that we just made. And I'm going to say, hello. And on the left side, you can see, okay, hi. We have the chat working. And now what Jim can do is Jim can also start adding things. And when Jim adds things, that will also be reflected in real time across to the other user. So thank you everybody for joining this brief demo of our CVSST software. I hope you have enjoyed this sneak peek so far. Hopefully you can join us next Friday for the live presentation and demo. Thank you.